The National Electrical Code requires that electrical outlets be installed with the ground prong facing up. This is because the ground prong is designed to make contact with the metal grounding pin in the outlet box, providing a path for fault current to safely flow back to the electrical panel. If the ground prong were installed facing down, it would not make proper contact with the grounding pin, potentially creating a safety hazard. In the event of an electrical fault, the current would not be able to flow back to the panel, increasing the risk of electrical shock, electrocution, or fire. Apart from safety concerns, there are also other practical reasons why standard plugs are not manufactured with the ground plug facing down. Firstly, orientation of the cord. With the ground plug facing up, the cord is suspended away from the ground, preventing it from coming into contact with moisture or debris. If the ground plug were installed facing down, the cord would hang lower and be more susceptible to damage. Secondly, cord management. Installing the plug with the ground plug facing up allows the cord to be more easily managed and routed. It prevents the cord from dragging on the ground or becoming tangled. Thirdly, aesthetic appeal. Most people are accustomed to seeing outlets with the ground plug facing up. Installing it facing down may appear unconventional and visually unappealing. If the customer insists on having the ground plug facing down, one possible alternative is to use a side ground plug. Side ground plugs have the ground prong extending laterally from the side of the plug, allowing it to make contact with the grounding pin even when the plug is installed horizontally. However, these plugs are not as common as standard plugs, so availability may be limited. Another option is to install a tamper-resistant outlet, which has a plastic shutter that covers the slots until a plug is inserted. Tamper-resistant outlets are typically installed with the ground prong facing up, but they can also be installed sideways or upside down. This would allow the ground prong to face down, while still maintaining the safety feature of the tamper-resistant outlet. The purpose of the grounding system is to provide a low impedance path for fault current to return to the source, which allows the overcurrent protective device, such as a circuit breaker or fuse, to quickly trip and to energize the circuit. This protects people from electrical shock and prevents damage to equipment. The ground fault circuit interrupter, or GFCI, is a device that protects people from electrical shock by monitoring the current flowing in a circuit. If the GFCI detects a difference in current between the hot and neutral conductors, it will quickly trip and energize the circuit. GFCIs are typically required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Electrical codes are in place to ensure the safety of electrical installations. These codes are developed by organizations such as the National Fire Protection Association, or NFPA, and are adopted by local and state governments. It is important to follow electrical codes when installing or repairing electrical systems. Improperly installed electrical systems can be dangerous and can lead to electrical shock, fire, or other hazards. When working with electricity, it is always important to take precautions to protect yourself from electrical shock. Some basic safety tips include turning off the power to the circuit before working on it, using insulated tools, and wearing rubber gloves and shoes. It is also important to be aware of the potential hazards of electricity and to avoid contact with live wires. Electrical systems are designed to operate at specific voltages. It is important to use the correct voltage for the equipment being powered. Using the wrong voltage can damage equipment or create a fire hazard. In North America, the standard voltage for residential electrical systems is 120 volts. However, some appliances, such as clothes dryers and electric ranges, require 240 volts. Commercial and industrial electrical systems may use higher voltages, such as 208 volts, 277 volts, or 480 volts. Electrical circuits are protected by overcurrent protective devices, such as circuit breakers and fuses. These devices are designed to trip and energize the circuit if the current exceeds a certain level. This protects the wiring from overheating and prevents fires. Circuit breakers are resettable devices that can be used to restore power to a circuit after it has been tripped. Fuses are one-time devices that must be replaced after they have been blown. Electrical wiring is available in a variety of sizes and types. The size of the wire is determined by the amount of current it will be carrying. The type of wire is determined by the application for which it will be used. For example, non-metallic sheathed cable, or NM cable, is commonly used for residential wiring. Armored cable, or AC cable, is used in areas where the wiring needs to be protected from physical damage. Conduit is a metal or plastic tube that is used to protect electrical wiring. Conduit is typically used in commercial and industrial applications. Electrical boxes are used to enclose electrical connections. Electrical boxes are available in a variety of sizes and shapes. They are typically made of metal or plastic. Electrical connectors are used to connect wires together. Electrical connectors are available in a variety of types. They are typically made of metal or plastic. When working with electrical systems, it is important to use the correct tools. Some common electrical tools include wire strippers, pliers, screwdrivers, and voltage testers. Wire strippers are used to remove the insulation from electrical wires. Pliers are used to grip and bend electrical wires. Screwdrivers are used to tighten and loosen screws. Voltage testers are used to check for the presence of voltage. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. Multimeters are essential for troubleshooting electrical problems. Electrical codes and standards are constantly being updated. It is important to stay up to date on the latest changes to ensure that electrical installations are safe and compliant. Resources such as the National Electrical Code and training courses offered by organizations such as the International Association of Electrical Inspectors, or IE, can help to stay informed. Understanding the fundamentals of electricity is essential for anyone working with electrical systems. This includes knowledge of voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical charge. It is measured in ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. Ohm's law is a fundamental law of electricity that relates voltage, current, and resistance. Ohm's law states that voltage is equal to current times resistance, or volts equals amps times ohms. Understanding Ohm's law is essential for calculating the values of electrical circuits. Series circuits are circuits in which the components are connected in a single path. In a series circuit, the current is the same throughout the circuit. The voltage is divided among the components in the circuit. Parallel circuits are circuits in which the components are connected in multiple paths. In a parallel circuit, the voltage is the same across all of the components in the circuit. The current is divided among the components in the circuit. Electrical diagrams are used to represent electrical circuits. Electrical diagrams use symbols to represent the various components in the circuit. Understanding electrical diagrams is essential for troubleshooting electrical problems. Electrical troubleshooting is the process of identifying and repairing electrical problems. Electrical troubleshooting requires a systematic approach. It is important to start by gathering information about the problem. Then, use a multimeter to check for voltage, current, and resistance. Finally, use the information gathered to identify the cause of the problem and make the necessary repairs. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which allows the overcurrent protective device to quickly trip and energize the circuit. This protects people from electrical shock and prevents damage to equipment. Grounding systems must be installed according to the requirements of the National Electrical Code. Bonding is the process of connecting all of the metal parts of an electrical system together. Bonding ensures that all of the metal parts are at the same electrical potential. This reduces the risk of electrical shock. Bonding systems must be installed according to the requirements of the National Electrical Code. Surge protection is used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protection devices, or SPDs, are designed to divert surge current away from sensitive electronic equipment. SPD should be installed at the service entrance and at individual pieces of equipment. Electrical inspections are conducted to ensure that electrical installations are safe and compliant. Electrical inspections are typically conducted by local or state government agencies. Electrical inspections can help to identify potential hazards and prevent electrical problems. Regular electrical maintenance is essential for ensuring the safety and reliability of electrical systems. Electrical maintenance should include inspecting wiring, connections, and equipment for signs of damage or wear. Electrical maintenance should also include testing of recurrent protective devices to ensure that they are functioning properly. Working with electricity can be dangerous. It is important to take precautions to protect yourself from electrical shock. Some basic safety tips include turning off the power to the circuit before working on it, using insulated tools, and wearing rubber gloves and shoes. It is also important to be aware of the potential hazards of electricity and to avoid contact with live wires. If you are not comfortable working with electricity, it is best to call a qualified electrician. An electrician has the training and experience to safely install and repair electrical systems. Electrical safety is everyone's responsibility. By following safe practices and taking precautions, we can all help to prevent electrical accident. The information provided here is for general educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before undertaking any electrical work. Remember to always prioritize safety when working with electricity. Your life and the lives of others may depend on it. The NEC is updated every 3 years, so it's important to stay informed about the latest changes. Changes to the NEC can impact the way electrical systems are installed and maintained. Understanding these changes is essential for ensuring compliance and safety. Continuing education is crucial for electricians and other electrical professionals. Continuing education courses can help to stay up to date on the latest technologies and best practices. Many organizations offer continuing education courses, including trade schools, community colleges, and professional associations. Obtaining the necessary permits is essential before starting any electrical work. Permits ensure that the work is inspected and meets the requirements of the local electrical code. Permits can be obtained from the local building department. Working without a permit can result in fines and other penalties. When selecting electrical equipment, it is important to choose products that are listed by recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the product has been tested and meets safety standards. Using UL listed products helps to ensure the safety and reliability of electrical installations. It is important to properly label electrical panels and circuits. Labeling helps to identify the purpose of each circuit and makes it easier to troubleshoot problems. Labels should be clear, concise, and easy to read. They should also be updated whenever changes are made to the electrical system. Proper documentation is essential for electrical systems. Documentation should include electrical diagrams, panel schedules, and inspection reports. Documentation helps to track the history of the electrical system and makes it easier to troubleshoot problems. It is important to keep documentation organized and accessible. Regular inspections can help identify potential problems before they become major issues. Inspection should be performed by a qualified electrician. Inspections should include checking for loose connections, damaged wiring, and other signs of wear and tear. Addressing any problems found during inspections can help to prevent electrical fires and other hazards. When making electrical repairs, it is important to use the correct parts and materials. Using the wrong parts or materials can compromise the safety and reliability of the electrical system. Always consult with a qualified electrician before making any repairs. Ensuring proper ventilation around electrical equipment is essential for preventing overheating. Overheating can damage equipment and create a fire hazard. Equipment should be installed in a location that allows for adequate airflow. Vents and other openings should not be blocked. Regular cleaning of electrical equipment can help to prevent dust and debris from accumulating. Dust and debris can cause equipment to overheat and malfunction. Equipment should be cleaned with a vacuum cleaner or a soft cloth. Avoid using water or other liquids to clean electrical equipment. Consider the long-term maintenance costs when selecting electrical equipment. Some equipment may require more maintenance than others. Choosing equipment that is easy to maintain can help to reduce cost over the long term. It is also important to factor in the cost of replacement parts. Review the manufacturer's instructions carefully before installing or operating any electrical equipment. The instructions provide important information about safety and proper operation. Following the manufacturer's instructions can help to prevent accidents and ensure that the equipment operates correctly. When working with electrical equipment, it is important to be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can occur when electricity jumps between conductors. Arc flash can cause serious burns and other injuries. To protect yourself from arc flash, wear appropriate personal protective equipment, or PPE, such as a face shield, gloves, and flame-resistant clothing. Maintain a safe working distance from energized equipment. Use insulated tools to avoid contact with live conductors. If you are not qualified to work on energized equipment, de-energize the equipment before starting work. Consider the potential impact of electrical work on other systems in the building. Electrical work can sometimes affect other systems such as fire alarms, security systems, and HVAC systems. Coordinate with other trades to minimize disruptions and ensure that all systems continue to operate safely. Communicate clearly with building occupants about any electrical work that is being performed. This can help to prevent misunderstandings and ensure that people are aware of any potential hazards. Provide advance notice of any planned power outages. Post signs to warn people of any electrical work that is in progress. Take steps to protect sensitive electronic equipment from power surges and other electrical disturbances. Surge protection devices can help to protect equipment from damage. Uninterruptible power supplies, or UPSs, can provide backup power in the event of a power outage. Be aware of the potential for static electricity when working with electronic components. Static electricity can damage sensitive electronic components. To prevent static electricity, ground yourself before handling electronic components. Use anti-static mats and wrist straps. Avoid wearing clothing that is likely to generate static electricity. Take steps to prevent water from entering electrical equipment. Water can cause short circuits and other electrical problems. Equipment should be installed in a location that is protected from the elements. Use waterproof enclosures and fittings to protect equipment from water damage. Be aware of the potential for electromagnetic interference, or EMI, when working with electronic equipment. EMI can interfere with the operation of electronic equipment. To reduce EMI, use shielded cables and enclosures. Keep electrical equipment away from sources of EMI, such as motors and generators. Follow industry best practices for electrical safety. There are many organizations that publish best practices for electrical safety, such as the National Fire Protection Association and the Institute of Electrical and Electronics Engineers, or IEE. Following these best practices can help to ensure the safety of electrical workers and the public. Stay up to date on the latest electrical technologies. The electrical industry is constantly evolving. New technologies are being developed all the time. Staying up to date on the latest technologies can help to improve the efficiency and safety of electrical systems. Attend industry conferences and trade shows. Read industry publications. Take continuing education courses. By following these tips, you can help to ensure that electrical systems are installed and maintained safely and efficiently. Remember, electrical safety is everyone's responsibility.